Alright, so now that we've talked about induced magnetism, we can talk about a specific application of induced magnetism, which is called an electromagnetic relay. These are used very often in automobiles and other applications as well, including machinery that might be in like assembly plants and things like that. Anywhere where you need a control circuit kind of thing, you might have an electromagnetic relay. In some cases, these have been replaced by more smaller electronic components. But relays do still have purposes, and they are still used quite commonly for certain applications. So let's talk a little bit about what it looks like. This is an actual relay that you see here. This armature is basically an electrical contact that is magnetic, so it's probably either iron or possibly steel, but probably it's iron that has a coating to prevent rusting. And it's going to be attracted to this coil when the coil is active, right? So this thing's going to get attracted to the coil, and that's going to move these contacts, these electrical contacts over here, and that's what basically turns the relay on and off. It's a switch that is operated by an electromagnet. All right, over here you've got a spring. The spring holds the armature open or off, except when the coil is magnetized, and then attracts this, pulls against the spring, and closes the contacts in order to activate the relay. All right, so that's basically how a relay works. I'll show you on the next page in diagram form. All right, so here we have two different diagrams. This one's more detailed. I'll go through this. This is what it looks like when it's off, and that's what it looks like when it's on. So let's zoom in on this one and talk about the parts here in more detail. So this is what the inside of a relay might look like. Here we have the coil of wire as a diagram form, and then I've highlighted this half of the circuit, which is separate from this half of the circuit. A relay has two different circuits. We could call it A and B for simplification. This side, this blue side, is the control circuit, and then this red side is called the load circuit. Typically, the reason you use a relay is so that the control circuit can have low current. It does not take much current in order to activate this electromagnet enough to pull that switch closed. So this can be a very low current, very low voltage, low cost circuit right here. You don't need a huge amount of power in this part of the circuit. In fact, just a very small amount in order to activate the coil and turn on the switch. All right, or close the switch, which turns on this current over here. So this is really important. A relay has two separate circuits at least. I mean, relays can be more complicated than this, but a simple relay has two circuits, one of which is the control circuit, and then one of which is the load circuit. And what do I mean by load? I mean that this is the half of the circuit that's actually connected to whatever it is you're trying to control. All right, a load, some electrical device. As I said before, this is often used in cars. So possibly this would be like a fog lamp. It might be a really powerful horn. It might be a very expensive sound system that uses a lot of current. There are a lot of things that this circuit might be connected to that's going to require a high current. And you don't necessarily want all of the circuitry that's being used for this thing to be high current circuitry. It costs more. It's more expensive. So, and of course, there's higher current running through it, so you don't want that necessarily all throughout your whole car. So in the part of the circuit that controls whether this is on or off, you want maybe low current, less expensive wiring. And then in the part of the circuit that's actually going to control the device, you might have your higher current and your higher power supply over here. All right, so that's important. Two separate circuits, two separate power supplies. This one's going to be a high current in the load circuit, and this one's going to be a low current in the control circuit. All right. So this then would connect up to the rest of the circuit, which is going to include a switch for the control side, and then this would connect up to the rest of the circuit, which includes your load on that side. So basically this activates a magnetic field, becomes active, and it attracts this switch. The switch closes to the contact, and that turns the electromagnet, or that turns the relay on. All right, now it's closed. Now current can flow. to the device, whatever it is that you're operating. And there you go. So a low current here activates an electromagnet. The electromagnet attracts this switch, which pulls it closed against its electrical contacts, and that allows the power supply over here to operate whatever the load is that you're running. And then the power supply over here is what allows this to run. Usually there will be a switch. For example, many of you probably have a car that when you open the door, maybe the flashers come on the car for a while, outside in the headlamps. So you might have this switch in the door connected to a power supply and a relay. You open the door, that activates the switch, right? Activates the electromagnet, this closes, and then that causes the flashers to flash. Until you close the door, which of course then turns this switch off, and that turns this off, and everything turns back off again. So that would be an example of how you might use a relay in order to activate something. Like I said, they're used very commonly in cars. Okay, so why would we use a relay? Well, we just talked about it in talking about the design. The number one reason is that it allows a low current circuit, that control circuit, to control a high current circuit, which would be the load circuit. All right, so it basically allows you to have a low current circuit that's very low budget, cheap, inexpensive, safe, and that allows you to control a higher current circuit, which is maybe far away in the car, and you don't want that much wiring going all through everything. That's all high current wiring. You don't need all that. So you can have the low current wiring by where the switch is, the control part, and then you can have the high current wiring actually by the load, whatever it is that you're trying to control. All right. Number two, it allows for more flexibility in controlling the circuit from a distance. So like I said before, if you're controlling the flashers in the headlights, that's pretty far away from the door. That would require a lot of extra wiring if you tried to put a switch directly to them and the door, and besides which that would make it limited. Basically the door would only be able to control flashers, but sometimes opening a door also turns a light on inside and other things like that. So if you want a single control switch to be able to control several different things, then that's a great time to use relays. Number three, it's more cost effective because low current circuitry is less expensive than high current circuitry. That's just the way it is. And then fourth, they allow flexibility and automation in the kinds of circuits that you can set up. So basically relays are more flexible than just using switches and wires. Relays let you do a lot more things, and they can give you some automation capabilities that are not possible with just switches and wires. So, all right. That's the basic idea of relays and how they're used, especially, like I said, I focused on cars because they're very commonly used in cars, and you guys all have experience using cars, I'm sure. So, anyways, I hope that was helpful in understanding how a relay works, and thanks for watching. We'll see you next time.